Thank you very much. Yeah, so I'm in front of this enormous cabinet of beer, so that's I might just grab those as I'm going when I finish this delicious glass of white wine. First of all, I just want to say thanks very much to Emily, who's done a fabulous job of organising tonight and putting everything together. So the folks at Betfair got her these lovely flowers. Say thank you.
I know. Thank you very much.
You're welcome. So thank you, Emily, and. Yeah, I co-authored this book. I'm just about to finish this book, and I work at this place. And I'm going to give what's kind of like not a very deep technical talk, which was the one that you decided you want me to give. But I'll try and give it quite quickly, so we have lots of the time at the end for discussion. So just in case you want to just drink beer and kind of go off and kind of have a relaxing evening without listening too hard, this is what I'm going to say in short, which is projects are evil and they must die, to quote Evan Botcher. There's this thing in agile where agile basically is kind of this bit in the middle of an enormous kind of disaster, and as the reason agile has failed in so many enterprises is because we've addressed the technical bit and not addressed the other stuff around it, and that's not good enough, and you can only ever get kind of 5-10% productivity improvement by doing that, and it's no good unless you fix all the other stuff in the enterprise, which is annoying because that's hard to fix, but the reality is if you don't do that, you're not going to see the benefits, and that's why so many people have, one of the reasons why so many people have had kind of agile failures is because, well, you didn't actually address the whole value stream, and these are the problems fundamentally. Everyone's so keen on tools. I work for a tool vendor. It doesn't matter. People are like, should I use Git or Mercurial? Yes, you should use Git or Mercurial. It's fine. People spend so much time on that, and actually the problems of process and culture and architecture. Architecture is the other problem. Continuous delivery requires you to architect for testability and deployability, and if you try and retrofit it onto systems that weren't designed with that in mind, it's not going to work. We've all experienced the misery of projects. Projects basically came from the kind of military-industrial complex, the NATO software engineering conferences of 68, 69, where they basically had to work out how to do large-scale software development to build bombs and spaceships and aeroplane systems. And it was designed for things that don't change much once you build them. You don't discover significant information in the course of building them, and they have to be finished before you start using them. And none of those things is true of software-based products. So it's fundamentally an unsuitable paradigm for doing software development because none of those characteristics apply. And so, we had the methodology wars. This is a diagram that I actually stole from someone in Japan, which was their actual process for building stuff, which made me sad because it was like 2 years ago. It's really ironic. So I went to Japan to speak at Agile Tokyo, and I was like, so software developers of Japan, there's this thing called lean thinking that maybe you've heard of, and that works in software too. You should really do that. That's great. So that was kind of weird, and they were like, yes, we know. The news is obviously Agile kind of won, but it kind of didn't win because the reality today is what we have is not Agile, it is water scrum fall, where, yes, we're doing these kind of nice iterations in the middle, but actually at the front it still takes months and months to get, the budget approval for the project, and then you have to get all the requirements, and then there's a great story from Dan North. So when I was working at ThoughtWorks, we used to have an award for the most career-limiting move. And one year, Dan North got this. Basically, he walked into a client, and there was a big stack of requirements on the desk. And they were doing an agile transformation. He's like, well, first thing about agile, won't be needing that. Took it, put it in the bin. Client principal had some work to do to fix that particular relationship. But that's the reality. You spend months and months building these things, and then the agile engineering team doesn't actually have any choice in what they get to build at all, or any say in what's being done. And then, you're working these nice iterations, but nothing actually gets released at the end of those. You still have, integration, QA cycles, and then there's a big list of bugs. And, in the Gantt charts for releases, there's always a phase to find the bugs and never a phase to fix the bugs that you found, which is kind of weird. But then the whole thing gets tossed over the wall to, release IT operations to try and make this thing work, and that's miserable. And so, continuous delivery was basically built on a bunch of stuff that me and a number of people at ThoughtWorks and the wider community were doing throughout the last decade to try and solve this problem. And the name of the book basically came from the first principle of the Agile Manifesto, which is this. But I'm not going to talk much about continuous delivery until the end. Instead, I'm going to reflect on this this second phrase in italics, which is valuable software, because that's kind of a problem. I mean, I actually I worked for ThoughtWorks Studios for a while, which is a product company, and I was the product owner, and I thought, well, let's see what Scrum says about being a product owner. And Scrum basically says, write a bunch of stories, prioritize them, go to the showcases, say if you think it's all right, Bob's your auntie's living lover. And I did that. I wrote loads of stories, I prioritized them, I went to the showcases, I was like, that's good, don't like that so much, we should fix that. But, you know, I have to say, that wasn't an enormously successful strategy for me, frankly. And so as a result of that, I kind of went through several years of kind of recovering from that experience, which was actually pretty painful and unpleasant, both for me and my family, because I'd like wake up in the middle of the night being like, oh, we're not making any money, oh, and then go back to sleep again and be like, I'll be all right. And so I just want to reflect on this kind of idea of valuable software. What is value? What is value? So I kind of went into this thing, what is value? So there's this concept of shareholder value, which is from these academics, Jensen and Meckling, the theory of the firm. They come up with this idea that what we should be doing is maximizing profits. So profit maximization is the job of corporations, and in fact in the US it's law. You have a fiduciary duty to maximize profits. If you're a director of a public company, that's what kind of governance is about. The problem is that turns out not to work as a strategy for maximizing profits, which is somewhat ironic. So if you look at the data, there's a book by John Kay called Obliquity. There's another book called Fixing the Game. If you look at what happens from 1980 to 2000, when this model was in full force, there's been a decline in the rate of return both on equity investment and investment capital. So like rate of return on investment has gone down as we pursue this model. However, someone has benefited from this model very substantially. Anyone care to guess who it might be? CEOs is the correct answer. Thank you, Ivan. So yeah, an 8-fold increase in CEO compensation from 1980 to 2000, because basically CEOs get compensated by shares to make them try and maximize profits on a quarterly basis. And so because you have this kind of quarterly horizon and you don't think any further of that than that, everyone's locked into this very short-term thinking, and no one thinks about the long-term consequences of their actions, because legally you're not supposed to do that. And you know, there's this idea that actually, you know, the long-term consequences of your actions will be reflected in the share price because there's complete transparency of information flow. It turns out that's one of the many things in economic theory that actually isn't true in real life, and so it doesn't work. So I got this great quote from Jack Welch, which I really like. So Jack Welch was CEO of GE. He says, shareholder value is the dumbest idea in the world. It's a result, not a strategy. Your main constituencies are your employees, your customers, and your products. Jack Welch has lots of good quotes. There's another one where he says, executives like to blab and blab about culture, but the employees know who the real jerks are, which is another great quote from Jack Welch. So, you know, he's great because he has this kind of like mildly potty mouth without actually swearing. So, you know, you can quote it in the company of children. Which I have. So I kind of, actually at the instigation of Nat Price, I went through and looked at some mission statements of various companies. The favorite one I actually found was SpaceX. So I looked at SpaceX's mission statement. So this is the module that docked about a year ago with the ISS, which is the first private module to actually dock with the ISS. And they went from nothing to building this in about 10 years, which is amazing. So the mission statement is this. The company was founded in 2002 by Elon Musk to revolutionize space transportation and ultimately make it possible for people to live on other planets, which is a great mission statement. I love that mission statement because, you know, in his spare time, he also co-founded Tesla Motors. Tesla Motors' mission statement is, Tesla Motors was founded in 2003 by a group of intrepid Silicon Valley engineers who set out to prove that electric vehicles could be awesome. Which is another great mission statement. And the good news is you don't have to be Elon Musk and a multi-millionaire who's also incredibly brilliant in order to make money and be a fabulous entrepreneur. So I'm going to introduce you to Jack Andraker, who I think was 15 years old when he won the Intel Science Fair in 2012 for creating a new diagnostic tool for pancreatic cancer after his uncle unfortunately died of pancreatic cancer. And so, you know, he managed to wangle his way into lab access in a lab and read a bunch of stuff on Google and ended up creating a diagnostic test for pancreatic cancer using carbon nanotubes coated with antibodies that was 100 times more selective than existing diagnostic tests, 168 times faster, 26,000 times less expensive, and 400 times more sensitive. So basically it was the bomb. And this is like 15-year-olds. So that's pretty cool. So I've got a couple of kids, and I would quite like them to be a bit like Jack and Draker. So I kind of went and looked at his interviews and found out what their parenting strategy was like. Yeah, so how do I reproduce this parenting strategy, which is clearly quite good. And so this is what he says. His parents, he says, never really answered any of the questions they had. Go figure it out for yourself, they'd say. I got really into the scientific method of developing a hypothesis and testing it and getting a result and going back to do it again. Which, as a parenting strategy, that's something I can do. I think I'm capable of following that parenting strategy. So I'm going to try it out, see how it works out. Seems quite high risk as a parenting strategy, I've got to say. But maybe if you're really disciplined about following it, then it'll work out. And, obviously you have lots of equipment and prisms and good books and stuff like that, and the internet. So this is really nice because it basically answers the question of what is value that I had as a product owner, which is how do we build things that are valuable? Well, there's only one person who can tell you if what you're doing is valuable, which is your customer. Don Reinertsen has a quote. He says, "The way people tell you whether what you're doing is valuable is whether they send you money." Which I think is a great quote. And so this is the whole basis of the lean startup. So, trendy kind of very 2 years ago, kind of blue and green colours and all this nice fonts and all this kind of thing. So I'm sure everyone in the audience is familiar with the lean startup, but if you're not, don't worry, because it's not actually new and trendy. It's something that's several hundred years old, which is the scientific method, which is whenever you're doing product development, you create a hypothesis as to what your customers might find valuable. You run an experiment to determine with the minimum possible effort whether that thing will actually be valuable, and then you get feedback and use that to work out what to do next. And this is actually really, really difficult for engineers, because engineers hate building minimum viable products because they want to build all this stuff so that people are like, wow, you're so amazing, so they can go, yeah, I'm so amazing, I'm an engineer. And get over years of abuse as a child. So that, and I understand why these psychological forces act, but it's actually unfortunate because speaking from experience, I once worked on a project where we spent years and a lot of money building this project, which was very successful in terms of finishing on time and on budget with the agreed scope. The company I was working for, which was building the software, made a bunch of money, and then we went off and did other stuff. And then I met someone 2 years later who was like, I was like, oh, so how did that thing go? And they it bombed. We lost loads of money. It was a disaster. And, we never got that feedback because our criteria for success was on time, on budget, in scope. And that's totally irrelevant as a measure of value, and we don't even normally measure the value of what we're doing because it's too hard, and even if you had that information, it would be impossible to work out which of the things you did were actually delivering value to your customers anyway. So this is quite good. I like this, but there's a problem with it, which is that it kind of sounds like a load of crap, because no one does this, right? It's a crazy thing to do. So I was visiting. So I know some people went to Velocity in Barcelona. Who went to Velocity in Barcelona last week? Okay. Did any of you go to Sagrada Familia? Okay, so Sagrada Familia is really, really cool. It's this thing. It probably looks a bit better than that now. That was taken a few years ago. But it's this crazy building that's been under construction for, I think, around 120 something years. By a guy called Gaudi, who was a very awkward child. He spent a lot of time studying nature, and there's a great quote from him where someone's like, well, Mr. Gaudi, it's taking quite long to build your church, and he was like, my client is not in a hurry. And so this thing is still under construction, and it's really amazing because it's built using these kind of hyperbolic principles of architecture. So he was really into nature, and he studied kind of the way that plants grew and shells and so forth, and looked at these hyperbolic structures that were inside these things, and basically said, well, what if we built buildings using hyperbolic curves instead of straight lines, which were more popular at the time. And of course, what you don't want to do is come up with a completely new paradigm for architecture and build an extremely big building using it and then find out if it's actually architecturally stable, because that's quite risky. And in fact, he didn't do that because he was reasonably sensible. So if you go down to the crypt of Sagrada Familia, what you can see, he did these really cool things. So there was no way of doing analytic modeling of forces acting on structures when he was doing this stuff. So he created an upside down. This is actually a church, a much smaller church that he built before he built the Sagrada Familia. And the way he modeled the stresses on the structure was he created an upside down model with all these weights and then model basically the tension instead of the compression in order to work out the forces acting on the different things. So he came up with all these ingenious ways to build small experiments to test the assumptions that he was making, his hypotheses about what would be effective, and he built loads of scale models. And so people say, well, if only we architects were building buildings like real buildings, that would be great, and we should do that in software development. And that's great if you're building structures with well understood characteristics like truss bridges, where there's an algorithm you can put the numbers in and get the numbers out the other end. But if you're building anything that's not well understood, that's actually not the way builders do things. They build, architects have prototypes and they do clever things and build smaller versions of things long before they build the real thing. And of course, that's very similar to what we do in software with prototyping and building out versions of things in order to actually understand what they're like. Because any kind of custom software project is a complex system, and you can't analyze complex systems analytically. So there's actually a lot more in common between kind of architecture and kind of software development than we think, because we don't often see this side of things. We generally see people doing very boring structural engineering projects like building a house, which is not the kind of house that Gaudi would build. So the other example that people use to kind of say this is a rubbish idea is Apple and the iPhone. But I'm sure someone in the audience will know what Apple's first commercial product is. Was the first commercial product that Apple built?
Apple 1.
The Apple 1, which doesn't look like this. It looks like this. Very, very different. And it was something that they prototyped in the garage, and it looked like ass, and it didn't do very much, but it was really, really cool. This is an MVP. And even this thing, you can find out a bit. They're very secretive, but they did basically say there was a very small team that was building stuff off the back of a Mac and prototyping this in a lot of detail. Apple has this nice thing where they are the consumers of their own products. So the way they work out whether what they're doing is valuable is if they like it, which is a nice position to be in. And most of us aren't in that position. We're in the position where people who are not us are the consumers of what we build, and then it's much more difficult because you can't use your own intuition as to whether or not you like something in order to determine whether or not it's going to be valuable. So Apple kind of have this nice situation where they don't have to do that. They just build things that they really like, and it just so happens that turns out to be, Steve Jobs has this kind of aesthetic sense that turns out lots of other people really like, but that's kind of coincidence, right? I don't think he set out to be like that. He did his own thing, and he found out what he loved, and he made things that he loved, and it just so happened that everyone else was like, holy fuck, that's amazing. But didn't have to be like that. And certainly if you're building medical devices, that's not true. There's a great quote. There's a whole website called folklore.org with stories from the creation of the original Macintosh. And if you look at the original Macintosh, this is my favourite quote. Instead of arguing about new software ideas, we actually tried them out by writing quick prototypes, keeping the ideas that worked best and discarding the others. We always had something running that represented our best thinking at the time. Which is basically continuous integration. And even at the hardware level, so Andy Hertzfeld, who designed the logic boards, was using programmable array logic in order to do that. And the great thing about PAL chips is that you can just reflash them. So if you have some new ideas about what logic you're going to build, you don't have to rebuild the whole circuit board, you can just reflash the PAL. So he designed the circuit board in such a way that he could use iterative prototyping methods in order to build out the hardware as well as the software. And they made that ability to be iterative about what they were building a core principle of the platform they built out. And I don't know, whether they did that on purpose at the time, but certainly in retrospect, it's very obvious that was a competitive advantage for them. And they were one of the first users of PAL chips at scale because it gave them this ability to prototype very rapidly with the hardware. So coming back to software, everyone presumably is familiar, with the story format as I want so that yay, right? So the agile story format. I kind of have a problem with this, and I have a problem with the word requirements as well. So we have this word requirements. Whose requirements are they? Are they the user's requirements? They're not the user's requirements. Users don't know what they want. Users know what they don't want once you've built it for them. So that's a quote from Steve Bell's Lean IT book, which I think is very true. They're the product owner's requirements. They're not the user's requirements. And this is the big problem with Scrum. I was a product owner and I did all the things that Scrum said I should do, and I built something that fundamentally wasn't that valuable to users because the requirements were my requirements, not my users' requirements. I think that was a major factor. So I really like this template. We believe that building this feature for these people will achieve this outcome. We'll know we're successful when we see this signal from the market. What's the signal from the market we're looking for to demonstrate this thing we're building is actually going to be valuable? How quickly can we get that information and use it to find out if what we're doing is actually worth doing at all? And I haven't got it. I'm going to do what I always do, which is open some other random slide deck because it hasn't got the slide I want right now. So who's come across Geico Adzic's impact mapping stuff? Yeah, so it's great because basically this is what impact mapping is just a mind map where you start with the kind of outcome that you want to achieve. What's the customer or organizational outcome? And then you look at the various personas who have a stake in that. And then you look at possible ideas for the features you could build and the assumptions around them. And from this, you have all the information you need to fill in this template. Now, building this feature, introduce new order types. For these people, for the traders, will achieve this outcome. This is the outcome we're trying to achieve. We'll know we're successful when we see this signal from the market, and these are the signals we're looking for. Reduce non-standard orders. Does doing this actually reduce non-standard orders for these customers in order to achieve this outcome? So there's this really nice kind of correspondence between this thing which Jeff Gothelf, the Lean UX guy, came up with, and this thing that Geico Adzic got from some Swedish guy, I think. But these things all work together, and it's one of these happy coincidences where multiple people have come across the same idea at the same time, and it just makes sense. So I saw that, I was pretty happy. But that enables us to be much more honest about what it is we're doing and why we're doing it. So this is what companies like Etsy and Amazon and so forth do at scale. They basically try and you go through the impact mapping process and come out with what's the signal from the market we're looking for, try and discover that signal by building as little software as possible in order to validate the idea. And so, any major feature that Etsy are going to build, they put a feature toggle around it, and there's just Etsy is kind of interesting because it's a big PHP monolith. It's not a service-oriented architecture, it's not a component-based architecture, it's literally a big PHP monolith, and yet they're able to move incredibly fast and do all this incredibly cool stuff, which is great for me because I was saying PHP was awesome for years, and I was at ThoughtWorks where everyone basically laughed in my face when I said that PHP is great. So, but they can basically enable, say how many percentage of the users using the site are actually going to see this new feature idea, and they've got this great tool that they built, what's it called, Atlas, where basically you can see the A/B test output. So blue is the control, green is running the treatment, and you can see these are the business metrics they care about. Number of people who visit the cart, number of people who bounce off the site, number of pages you visit on the site, number of visits where something's added to the cart, and you can see if there's a statistically significant difference. So they're looking for a 95% confidence interval to demonstrate statistical significance. So page count, you can see there's an improvement of about 0.26%. Which for an A/B test is reasonably good. Normally you don't get more than a few percent in an A/B test, and if you do, it's normally an application of Twyman's law, which states that anything that looks amazing is probably wrong. So that's important, and AA tests are a way of validating that. And they always have a ton of experiments running in production at any one time, and the problem is we're not trained how to do this. Like running experiments, making sure those experiments don't interact with each other, being able to actually interpret the data from these things, that's not taught anywhere. And yet, if we're going to follow a scientific approach to product development, these are core skills that we all need to know and be teaching, and be teaching to new developers. And yet, Amazon won't tell you anything about this stuff because it's a competitive advantage for them. Etsy will tell you about this stuff because they want to recruit you to Etsy. No one's telling you this stuff because they think you should know it, because it's the bomb and people really don't know how to do it. And that's the reason why Etsy has this incredible deploy rate, is so that they can do A/B testing. I love quoting these stats from Amazon because they blow people's minds. Deploying to production every 11.6 seconds. Now this is aggregated across all Amazon services, of which there are tens of thousands in production, but still pretty impressive. And some of those services are deployed much more frequently than others, depending on the risk profile of the services, so that's something you want to take into account. But still, that's amazing, and certainly blows pretty much everyone else in the world out of the water. And I think this is like 3 years ago, and I think now they're approximately one order of magnitude faster at doing this. And the reason they do this is because most A/B tests don't deliver value. So Ronnie Kahavi, who designed Amazon's A/B testing framework, and then went on to work at Bing and designed Bing's A/B testing framework. Has a ton of data from A/B tests. 2/3 of those ideas turned out to make things either produce results that were not statistically significant or made things worse. And making things worse is not actually a situation that we normally envisage. We're like, oh, well, that didn't deliver any value. Guess what? About 1/3 of the time, you're not just not delivering any value, you're making things worse for your users and customers. And by the way, it's not just that. You've wasted the opportunity cost of the features you could have been building instead of the features that you did build that made things worse. And you've got to maintain those features forever in production because no one ever deletes features, and that becomes then extra bloat in your product that slows down the rate at which you can deliver new features. So it's incredibly painful. I mean, if you extrapolate this, we could be spending 2/3 of our working lives on vacation and deliver the same value to our customers if only we knew the 2/3 of the features we were building that delivered no value to our customers. It's the biggest source of waste in product development, and in the work that we do is the stuff that we build that's useless and we don't even know. Like, this for me is crack as a product owner. Like, I can see real data that tells me if my ideas are actually going to be valuable. It's amazing. Like, this should make you never want to build packaged software again. Because A/B testing lets you derive a causal relationship between the features you're building and the value it's delivering in dollar amount or pound amounts to, I've been in America too long, pound amounts to users, right? That's amazing. And no, I mean, if you can do this, like, you should like not worry about all your other architectural decisions just so you can do this, because it's amazing. Which is why Amazon invested in this, which was really, really expensive for them to do. So in 4 years, it was unbelievably expensive, and they did it because of this. So I just want to talk a bit about kind of other kind of cultural elements of this. Gene Kim, and Nicole Velasquez and Puppet Labs this year did the State of DevOps report, where we surveyed over 9,000 people to find out what people were doing and try and find out what practices people actually used in real life and whether they were valuable. And so it was quite cool. We found some really interesting results, some of which I seem to have foolishly deleted from this presentation, so I'm just going to switch to another one. Let's see who we are. Yeah, so number one thing is that, what's his name, Carr was wrong. IT is a competitive advantage. So we measured profitability, market share, and productivity goals self-reported, which is a standardized metric of organizational performance. And we also measured IT performance, and we found there was actually, a causal relationship. High-performing IT organizations were twice as likely to exceed their profitability, market share, and productivity goals. So what is IT performance? That's kind of a loaded term. The other cool thing is we actually found a statistically valid way of measuring IT performance. It's very difficult to get statistically valid models where this is IT performance. This is called a latent variable, and it's constructed from a bunch of other variables, dependent variables that we measured, and actually finding something where the variable which actually moves in a statistically significant way with the other variables actually is like gold dust in statistics. I don't know anything about statistics, but Nicole Velasquez is very, very clever, and she did all this work on to find this out. So this is actually a statistically significant measure of IT performance, and it focuses on two things: throughput, which is measured by lead time for changes and release frequency, and then stability, measured in terms of time to restore service and change fail rate. So these are the things that you should measure if you want to measure IT performance, and these predict organizational performance. They're not the biggest predictor of organizational performance. The biggest predictor of organizational performance is job satisfaction, which is, would I recommend this as a good place to work to other people? Do I have the tools and training I need to do my job? Am I satisfied with my job? And there's another one that I can't remember, but you can download the report. That's the biggest predictor of organizational performance, but IT performance is also a predictor of organizational performance. So we wanted to find out what practices correlate with IT performance. I love surveys because they're such a powerful source of confirmation bias, and I wasn't disappointed. So, code, app configuration, and system configuration are in a version control system is most highly correlated with IT performance. And actually, app configuration and system configuration are higher than code. So it's more important to have app configuration and system configuration in version control than it is to have your code in version control in order to achieve high IT performance, which is kind of interesting. Getting failure alerts, developers getting failure alerts from logging and monitoring systems, not from the Network Operations Center or Twitter, also highly correlated with IT performance. And then my favorite ones, developers merge their code into trunk daily, and developers break up large features into small incremental changes, both very highly correlated with high IT performance. So, feature branches of the world, I'm right. Yeah, and I've got the data that shows it. So, and then this is the DevOps thing. When development and operations teams interact, the outcome is generally win-win, rather than kind of passive-aggressive or aggressive-aggressive for that matter. And then using some statistical magic that I don't pretend to fully understand, we looked at what predicted IT performance. So this is a great one. Lots of people use change approval processes that are external to the team. So there's a change advisory board or some other team external way of managing changes going to production. So the data shows us that this external change approval processes significantly reduce throughput and do nothing to improve stability. So it's literally zero value add from a stability point of view, and actually peer review change approval processes like pair programming or lightweight code review processes much faster, achieve the same levels of stability in terms of time to restore service and change fail rate. So again, that's really great, and it confirms everything that we know, which is that these kinds of external processes are basically just risk management theatre and have nothing to do actually with improving the stability of our systems, because the idea that someone who knows nothing about your code base and how it works could possibly have an idea by inspecting the code changes of what the risk of those code changes is absurd in a complex system. So we know it's stupid, and we have the data that proves it's stupid, so we should stop doing it, especially in regulated industries where it actually matters. Version control everything, obviously, proactive monitoring, and then this thing, high trust organizational culture, and I'm going to talk about, and then the win-win relationship. I'm going to talk a little bit about high trust organizational culture and what that is and what it means. So some of you will have heard of John Allspore, who's VP of Operations at Etsy. So he's doing this PhD in safety systems in Sweden right now, because of his copious free time. And he basically, I'll occasionally ping him and say, hey John, how are you doing? And he'll email me back a PDF of whatever he happens to have been reading and be like, read this. And that's basically, John Allspore's PDF as a service thing that he does, which is great because they're always really interesting. And so this is a paper he sent me by a guy called Ron Westrom, who's a sociologist, who was studying safety outcomes in healthcare and aviation, which are domains where when things go wrong, people die, and that's quite bad. And so he created this model by which you can look at the culture of the organization, and this predicts safety outcomes in healthcare and aviation. And so I think you can probably all look at this and understand quite viscerally and immediately where you fall on this spectrum or the organization you're working for right now. And there's two things I want to focus on in particular. Novelty. Is novelty crushed? Does it lead to problems? Scope creep. Well, we should have this feature. Ooh, scope creep. That's a problem. Or is novelty implemented? Is it embraced? Do we embrace change? And what's most interesting for me is that a model that predicts safety outcomes also predicts IT performance and organizational performance. So the same things which make organizations safer also enable them to be more innovative and produce higher performance, which is really interesting. And then the other thing is, how do we deal with failure? Does failure lead to scapegoating? Does it lead to justice? Or does it lead to inquiry? And to understand why this is so important, we have to kind of think a little bit about complex adaptive systems. So every organization we work in is a complex adaptive system. And there's two characteristics in particular about complex adaptive systems that are important, which is number one, we can never have complete information about the state of the system. And then number two, even the CEO, especially the CEO. And then number two thing is, given a particular action, we can never predict entirely the consequences of that action. That's an impossible thing to do. And so this idea that we have, when something goes wrong, we perform an investigation, hopefully, and then that investigation, in pathological organizations, usually leads to us finding the person responsible and disciplining them or firing them. And that is to fundamentally misunderstand the nature of complex systems. In a complex system, you cannot predict the consequences of your actions. You never have complete information. So just anytime something bad happens, run this little thought experiment in your mind. If I had been that person in that situation with that information, could I have made the same mistake?
And if we're honest, the answer is usually that we could have, and that could have been me, which is exactly what the retrospective prime directive states. I mean, the retrospective prime directive is basically a statement that we all are working in complex adaptive systems. So it's crazy if failure leads to scapegoating, because that's to ignore the reality of our system and the fact that investigations should always result in working out how to improve the system, how to get better information to people, how to enable them to take actions, and if the consequences of those actions are bad, it doesn't destroy everything. So the outcome of inquiry should lead to creating more resilience and improving the system. And we should celebrate people who find these problems. Etsy has a developer conference every year where they give out, so their 404 page at Etsy is a jumper with 3 arms. And they actually give a jumper with 3 arms to the engineer who caused the biggest outage in production in the previous year. It's like, well done, you found something really bad, have this sweater, woo! It's good. And this is something that large-scale organizations have embraced. Google has this concept of disaster recovery testing, where once a year they run this crazy exercise. You can read about this. There's a great article in ACMQ by the woman who runs that program, who's called Kripa Krishnan, and she wrote about the kind of things they do. They basically plan out these whole scenarios like aliens invading Silicon Valley. And they plan the whole thing out and then actually execute it by doing things like turning off the connection between Mountain View and the rest of the world, and turning off fiber connections and switching off data centers. And they very meticulously planned it to at least allow the resources that are required, the bare resources that are required for all those systems to still operate, to operate. So they plan it so that it doesn't remove so many resources that the whole thing's going to come down. But they, keep it just above that threshold to make sure that it's real. They introduce failure into their systems. The only way to prove that you can survive a failure condition is to test it and simulate it. TDD has applied to disaster recovery, if you like. And this is what high-performance organizations do. They don't avoid failure. They actively create failure as a way to validate that they actually have the capability to deal with it, that the systems are in fact resilient, and as a way of actually enabling those different people working on those systems to create relationships with each other. Like in her article, she says, as a result of running these exercises, people have to communicate with each other who wouldn't normally talk to each other. And that's one of the biggest outcomes of this, is that these people now have relationships and they can work together. So high-performance organizations introduce failure so that they can improve their systems. So I guess the question probably on people's minds is, if you're over here, how do you get over here? And so I've got a really good story about that. I'll swap back to a different presentation again. So has anyone heard of NUMMI, the New United Motor Manufacturing Inc.? Okay, there's a couple of you. So NUMMI was this joint venture that was created by Toyota and General Motors in the 80s. And General Motors had this plant, which is about half an hour drive from where I live, called Fremont Assembly in California, which was California's only car assembly plant. And it produced the worst quality cars of any plant in GM North America. And relationships between the union workers and management are completely broken down, to the extent that the union workers would do things like, drinking on the job and gambling, and doing things like putting Coke bottles in the doors so that they would rattle when you shut them, like actively sabotaging the vehicles, because they were just like, and so what happened is GM shut down this plant. And then around the same time, they created this joint venture with Toyota because the US Congress had imposed trade barriers on Japanese cars because they were just too cheap. So Toyota wanted to build a plant in America to escape the trade restrictions. And equally, GM wanted to learn how to build small cars, which they didn't understand how to do in a profitable way. And they also wanted to learn about the Toyota production system. So they created this joint venture. GM chose Fremont Assembly as the site of the plant they were going to use for NUMMI. And then something crazy happened, which was that the union leaders at GM, the previous union leaders of Fremont Assembly, convinced Toyota's management to rehire the same people to work in that plant. And they took those people and they sent them to Japan, to Nagoya, to Toyota City, and retrained them in the Toyota production system. And they all came back to Fremont Assembly, and within a few weeks they were producing the highest quality cars of any GM plant in the whole of North America, and as good quality as any cars that were produced by Toyota in Japan. Same people. And what this tells us, in IT we have this thing about, you've got to hire the best people, the 10x people. And what this tells us is that is just frankly bullshit, because actually what's important is not the people, it's the system in which we operate. As W. Otis Deming says, a bad system will beat a good person every time. It's the systems and the management structures and the culture of the organisations that are much more important than the individuals that work within those systems. Unless they're very high-performing organisations, and then differences between individuals do start to matter. But most of the time, most of the organisations we work in, that's just not true. And so it's interesting to examine, what did Toyota do that caused this change? So there's a great podcast on This American Life which talks about the Numi story. It's really, really good. Can't recommend it enough. And then John Shook, who was Toyota's first American employee, Toyota Japan's first American employee, who was hired to train the workers from Fremont Assembly, wrote an article in Sloan Review about what they did. And basically what he says is, to change culture, this is Shine's model of culture. I haven't got his name here, but anyway, a guy called Shine, who wrote a book called, I'm really jet lagged, I can't remember it, but it's really good. I'll tell you afterwards when I can look it up. But anyway, there's three layers. There's kind of culture, which is kind of very implicit and you can't really see it. And then there's people's values and attitudes, like the mission statements that are written on the walls. And then there's people's actual behavior, what people do in real life. And people think that to change culture, you have to start down here and work up here. And that's not actually true. The way you change culture is by changing the way people behave, and that gradually percolates down and changes everything else. So, if you, and I'm going to change my slides again. All right, never mind. So here's what they did differently. If you look at a production line in Toyota, what you see is there's kind of markings on the floor. And so everyone working in a factory in Toyota basically has, oh, hang on. Okay. Yeah. Nah. Okay, never mind, I haven't got it. So they've got these little They've got these lines along the production line, and essentially what happens is the car moves along the production line, and you've got a certain amount of time to do whatever your job is, which might be, putting on a door before the thing moves on to the next work unit where someone does something else. And so in a GM factory, what happens is, the car comes along, you've got like this moving, and you've got to put the door on, and most of the time you put the door on, it's fine. Sometimes it doesn't quite work out, you don't have time to do it, it goes on to the next work unit, and that's it. I mean, the door's not on. Too late, goes on to the next work unit. And so what happens is, as a QC person, a quality control person, at the end of the production line, he basically looks at the car and is like, no door, fail, and it goes off into parking lot. Engine's the wrong way around, fail, and basically just stands there and just fails all the cars, and they get put in a parking lot and maybe fixed, or maybe they just turn into rust buckets. And so this is what happens at a typical GM factory. And at Fremont, basically most of the cars ended up in the parking lot and not saleable because no one cared. And this is not what happens in a Toyota plant. In a Toyota plant, what happens is, about 2/3 along the production, your part of the production line, if you haven't got your job done, you can pull a little cord called the andon cord, and a little yellow light lights up, and a tinkly little melody plays, and then a manager comes along, and the manager helps you. Right, so that was the first kind of shocker, is like, oh, really? They're not just going to be like, you're lame, you suck, like, work harder. They actually help you. And if you're not done by the time you get to the end of your work unit, you can pull the andon cord again, and another little jolly tune plays, and a red light goes on, and then the production line stops. And then, a bunch of other people come and you fix the problem, and then you start the production line again, and then later on you reflect on what you could do to make it so that that problem doesn't recur again. So this is basically the fundamental difference between Toyota production system and GM, is that the workers are empowered to build quality into the system rather than trying to inspect quality in at the end when it's too late. And they achieve that by people actually collaborating together rather than having this relationship which is based on, you suck and extrinsic motivation. And so this idea isn't actually new in Toyota. Does anyone know what Toyota was building before they built cars? That's right, looms. So their first breakthrough product was the Toyota Automatic Loom Type G. And the great thing about this loom is, so this is built, I think, in 1924. It's like 90 years ago. So what happens in this loom is it can automatically detect if there's a problem, and if it finds a problem, it stops. So prior to this loom, in order to have a factory, you have a room full of looms, and then you have a person in front of each loom looking at it, and when something went wrong, they would stop it and fix it. So they were literally just spending their day going like this. And then when something went wrong, they're like, oh, okay, stop it, fix the problem. With this loom, because it automatically detects problems and stops, what that means is you can have a whole room full of looms and only one person. Because when anything goes wrong, it stops and then you fix the problem, but you only need one person to do that, and they can probably be reading a book or something at the same time, which is nice. And it turns out there's an exact analog to this process in software development. Can anyone tell me what it is? Yeah, breaking the build. It's continuous integration. So continuous integration is actually a process that was invented 90 years ago in Japan by the people building the Toyota automatic loom, which is, we're going to check our code into chunk on a regular basis, and if there's a problem, we're going to stop immediately and fix the problem and then carry on, rather than just letting the build go red and not worrying about it, which is like, you're running the loom, and the loom stops, there's a problem, you're like, fuck it, right, so actually fix the build, right? And that is really at the core of what's different about the Toyota production system. And so the way I want to end it is basically by saying, we have the power to change culture, and the way we change culture is we change behavior, and the way we change behavior is by changing our daily routines and actually being disciplined about practicing these things where we focus on not how fast we can declare our code dev complete on a branch, but whether we've built something high quality that's shippable, and then gathered real data to validate whether our assumptions about whether it's valuable are actually true, and we optimize everything to get that cycle time as short as possible so we can get feedback as rapidly as possible, which is what the high IT performance organizations are doing. So I want to leave the last word to Jack Andraker. Jack Andraker, in the same interview, says this. He says, make sure to be passionate about whatever it is you get into, because otherwise you won't put the right amount of work into it. So I want to leave you with that thought. If you could get out of this room today and do anything you wanted and wave your magic wand, what is it you would do? What would you go out and do today? Have a think about that and then go and make it happen. Thank you very much.